Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Taufiq and my ID number is VB23037. And today I'm gonna present about the Taguchi method. Gonna go to the introduction first. Uh, to Taguchi method. Taguchi method of quality control is an approach to engineer that emphasizes the roles of research and development, which is R&D. The product design and development in reducing the occurrence of defect and failures in manufacturer. So this is basically the Taguchi method is more to the R&D development. So it more to reduce the defect and the failures in the product when doing a manufacturer. So this method is developed by Japanese engineer and statistician, which is Genichi Taguchi. He considers the design to be more important than the manufacturing process in quality control and aims to eliminate the variances in production before they can occur. So Genichi Taguchi is more to focus on the quality control and he want to eliminate the defect and the failures product. So he want the product to be completely in good condition. So we go to the objective of the Taguchi method. The first one is minimize the variation in product response while keeping the mean response on target. The second one is the product can be made robust to change in operating and environmental condition. Since the method is applied in a systematic way at the pre-production stage, which means offline, it can greatly reduce the number of time-consuming tests, thus saving costs in the wasted product. So as we know, Taguchi is to reduce the defect and failure product. So it use the way at the pre-production stage, so it can reduce the number of time when consuming the test. So it will save more time and cost, and it also can reduce the wasted product. So next, we go to the core concept. So the first one is loss function. Quality is the loss a product causes to society after being shipped, other than any losses causes its intrinsic function. By word loss, it refers to the following two categories, which is loss caused by variability of function, loss caused by harmful side effect. So basically, loss function is more to the product that cannot be used. So which is lost by function or lost by side effect. So which is defect. Okay. So this is the loss function. Uh, so the next one is orthogonal arrays. Arrays name indicates the numbers of the rows and column. It has and also the number of level in each of the columns. Forward orthogonal is one main requirement of orthogonality is a balanced experiment which mean equal number of sample under various test condition. So on the right side, there is example diagram that I take from the Google and I put it in here. So this is the example of the orthogonal arrays diagram. So in here we can see this is the robust design. Robust mean not just strong and tough, but also flexible, reliable, and efficient. Robust design mean develop robust product and process. Robust product and process are minimally impacted by external forces such as environment, client use, or manufacturing condition. So robust is more to the mm, product or procedures, and the product can uh, process and develop. So this is the example on the right side. So we can see the signal control factor, and noise factor go to the product and go to the response. So next we go to the philosophy of offline quality control. So this is the best opportunity to eliminate variation is during design of a product and its manufacturing process. So first we got the system design. Design at the conceptual level involving creativity and innovation. Second, parameter design. Nominal value of the various dimension and design parameter need to be set. The third one is tolerance design. Understanding of the effect that the various parameters have on performance resources can be focused on reducing and controlling variation in the critical few dimension. So basically, these three is to simplify the type of manufacturing process. So we go back to the orthogonal array. So as we can see, figure B shows the column design that defining relation which also required for runs can be used to estimate three main effect by assuming that all two-factor and three-factor interaction are unimportant. So as we can see on the on the left side of slide, there is a table that show the example of the orthogonal arrays table. So a comparison between the two designs shows that the column in the two designs are the same except for the arrangement of the column. So next, so this is the Taguchi two-level design. So basically, ha it has a difference on the table, and this is the Taguchi three-level design. So next we go to the signal to noise ratio. So on the left side of slide, we can see the formula that to calculate the noise ratio. So the function of signal to noise ratio is to measure the performance variation. So there's three types of common type that use in signal to noise ratio, which is larger, smaller, and nominal. So this is the example. So next we go to the quality loss function. Quantifies cost of quality loss. The formula, as we can see, L equal to K bracket Y minus T bracket and 2. So L stand for loss, Y stand for actual value, T stand for target value, K stand for constant. So this is the formula for quality loss function, and the right side is the uh, diagram that show what is more to the loss function. And next, we go to the 8 steps in Taguchi method. So the first one is identify the main function, side effect, and failure mode. The second one, identify the noise factor, testing condition, and quality characteristic. The third one is identify the objective function to be optimized. The fourth one is identify the control factor and their levels. The fifth one, select the orthogonal arrays metric experiment. This number 6, conduct the metric experiment. Number 7, analyze the data, predict the optimum levels and performance. And the last one is perform the verification experiment and plan the future action. So this is the X steps that used to check the product on the pre-stage production manufacturing, on the pre-stage manufacturing process. So we need to do this before the product is finalized and give it to customer. So this is the advantage and the limitation of Taguchi method. There's pros and cons for this method. So the pros is robust design, cost effective, simplifies experimentation, reduce variability, and enhance the quality. For the cons is limited scope, requires expertise, not suitable for all problems, potential for oversimplification, and data intensive. So this is the short pros and cons. So we go to the detail a little bit. So I have three advantage and three limitation. So we go to the advantage first. So efficiency in experimental design and data collection. One of the Taguchi method most significant advantage is its ability to study multiple factor simultaneously with a minimum number of experiment with use of orthogonal arrays. So if we want to take a data and uh, if we want to take a data for the product, we can use the orthogonal arrays. So the second one is robustness and insensitivity to uncontrollable factor. A core principle of the Taguchi method is achieving robust design that are insensitive to uncontrollable noise factor. By optimize control factor and minimize the impact of the environmental variations, the method enables the creation of product of or process that consistently perform well even under varying real-world conditions. The last one is for advantage cost savings through minimized defect and rework. By prioritize quality and robustness from the design phase, the Taguchi method helps organization reduce the defect, rework, and waste, leading to significant cost saving throughout the product lifecycle. This proactive approach to quality control is particularly valuable in manufacturing and production environment. So, it will make the cost more saving by doing a Taguchi method. So it the the product is not wasted. Okay. So next we go to the limitation. The first one is efficiency and statistical rigor. Some statisticians have questioned the efficiency of certain Taguchi proposal, particularly when it comes to handling complex interaction between factors. While the method excel in studying main effect, its approach to interaction has subject debate. Limitation in handling complex interaction. The second one. Due to the use of saturated orthogonal arrays, the Taguchi method may not fully capture or resolve higher order interaction between factors. This limitation has led to alternative approaches such as response-based methodology, which allows for more flexibility in studying complex interaction. The last one for limitation is lack of theoretical foundation. Critiques have been raised regarding the lack of solid theoretical foundation underpinning certain aspects of the Taguchi method, particularly the use of signal-to-noise ratio as objective function for optimization. So this is the comparison with other methodologies. So if Taguchi method compare with Six Sigma, Six Sigma is process the improvement. So what if Taguchi method compare with lean manufacturing? Lean manufacturing is more focused on waste reduction. And the last one, if Taguchi method compare with design of experiments, the design of experiment is focused on systematic experimentation. So this is the example application. So this is the microprocessor company that I found on Google that I don't know which company, but this is the example that I found. So this is the table that I hope this is the accurate data. And the second one is the solution. The L9 orthogonal array should be used. The field in orthogonal array should look like this. Yeah, they should like this. And there below the table, there is a calculation that using the formula from the orthogonal arrays. And next one is this is the result after the calculation. And after this page, it show the table, and there is one more calculation that we need to do before the final result. And so this is the effect of this factor is then calculated by determining the range. So it can be seen that the deposition rate has the largest effect on the processor yield, and that temperature has the smallest effect on the processor yield. So this is the comparison after doing the Taguchi method calculation. So the conclusion is Taguchi start to develop a new method to optimize the process of engineering experimentation. So basically, Taguchi approach to make sure the quality of the engineering, place great a deal of emphasis on minimizing variation, and Taguchi method uh, use the idea of fundamental functionality, which is facilitate people to identify the goal, because it will not change from case to case and can provide the robust standard for widely. So, Genichi Taguchi once said, cost is more important than quality, but quality is the best way to reduce the cost. So, this is the reference that I use to make this slide share. And that's all from me. My name is Ahmad Taufiq. Assalamualaikum warahmatullahi wabarakatuh.